ANSYS Simulation, Lecture 1, the structure of CA analysis. For the first time you run ANSYS, make sure that ANSYS is linked or connect with your CAD system. Choose ANSYS Utilities, CAD Configuration Manager, and you can connect or link Workbench with the CAD system. And make sure that the configuration is a success. And after that, you can open the CAD system and you can draw a model on the CAD software. For example, on XY plane, I enter sketch mode and draw a rectangle and extrude it into a brick. Save the file on desktop, for example. And in this problem, I'm not going to place any dimension on it to make the 3D geometry as simple as possible so we can concentrate on CA analysis. So first of all, we need to load the software. Tool, add in, or fast drop-down menu, add in. Add in the software, ANSYS. The left checkbox is to load ANSYS this time. The right checkbox is to load ANSYS whenever you open the CAD software. So we have loaded ANSYS onto the CAD software. We can enter ANSYS Workbench. And ANSYS Workbench is an interface for 3D ANSYS procedure. And the first interface we see would be project schematic. And this is an organizing interface for ANSYS Workbench. So this is the SolidWorks model, and we will drag static structure analysis and drop onto geometry. And there will be a link that feeding the CAD geometry onto ANSYS procedure. And this is the first step. The second step would be material, and the third is meshing the model. Step 4 will be boundary conditions and loading. Step 5, running the solution. Step 6, the result. So we finish with the first step, which is drawing a 3D model and from a CAD system and feed the CAD model onto ANSYS. The second step will be editing the material, and we'll enter material editing procedure and choose data source, the library of materials. And in general material library, we load aluminum alloy and copper alloy, for example. So now we have 3 materials loaded to the procedure: aluminum alloy, copper alloy, and the default structural steel. And we shut down or close the data source, and we have 3 materials chosen for this problem. And we'll go back to project, and then we'll enter the third step, which is editing the model, and enter ANSYS Mechanical. ANSYS Mechanical is a procedure where all the static structure analysis are implemented. So we enter the mechanical. The first thing we need to do is connecting or linking the geometry with the material. For the material, we have chosen 3 materials for this problem, and we can choose among them, for example, aluminum alloy for this part. Now we have finished with the first step, which is drawing of a model. The second, the material. And the third step will be meshing. Right-click the mouse and update the mesh. And for step 4, you have to click on the structure static tab in order to show the tools related to boundary conditions and loadings. If you click on meshing tab, the toolbars will show only items connected or linked to meshing. So you have to click on static structure in order to show the support and loading functions. So we choose fixed support for this surface. and apply. So this is a confirmation step, which is a very good function in ANSYS. And for loading, we apply a force on the top surface. The area on which the force applies, the direction of the force, choose this line and toggle up and down and confirm the direction and the magnitude of the force, 100 Newton. So make sure that you have defined all the three components of the loading: the area of the load, the direction of the load, and the magnitude of the load. These are the three components of loading. Since we have finished with step 4, we have actually completed the definition of the whole problem, and they are called preprocessors. So now we can go ahead and solve for the problem. But before we do that, we need to tell the software what result that we want. For example, we need total deformation and low mean stress, and then solve for the procedure. We can solve it here. And then you get the result for deformation and stress. So we get to step 6, which is the result. And this is the total deformation result. You can play the animation. You can play faster or slower. Faster, slower. You can play smoother. This would be 30 frames per second. So now you can also probe the numerical value of the displacement and also display minimum and maximum value. You can also show the result in different styles, and also you can show undeformed frames in different ways. And you can also show the vectors, the arrows, with longer arrows or shorter arrows, with color signifying the numerical value or not, the density of the arrow, and the types of the arrow. So you can play with all these result functions. And ANSYS also provide a report function, but you have to first add the figures so as to show the figures on the report. For example, I'll add these 3 figures and then generate report, and the report will have 4 figures. The first figure will be the model, the second will be the mesh, which I added here, and the third will be the displacement figure, and also the stress figure, which I defined here. So you can define, you can also generate report in ANSYS, but there's only in English version. There's no, for example, no Chinese version of report. But in other software, for example, in SolidWorks simulation, you can generate report on any other languages. So it is a more convenient way. But ANSYS offers only English version of report. And this is the 6th step for CA analysis. And this is very important, that the structure of CA analysis is always the 6th step: the geometry, the material, meshing, boundary condition and loading, and solving, and also the result. And these steps applies to all CA analysis softwares. For example, ANSYS, Nastran, Cosmos, or SolidWorks simulation, and also Console. All the general purpose CA analysis softwares applies to this 6-step structure of CA analysis. So this is very important, that anyone new to this field have to memorize the 6 steps in order to be able to implement these procedures.